Good morning. I'm Chris Webb, and I'm happy to be here. I'm an engineer with Herrera, and happy to be speaking with you about some of the common siting and design issues that are common to all of the permeable pavement types. And then we're going to take a more deep dive into each of the pavement types later. So right off the bat is site selection. Each of the permeable pavement types have different strengths, pros, cons, and price points and features that make their use appropriate in different settings. For example, reinforced grass paving with the cell systems is really nice for areas of infrequent use. It can really create an extension of the landscaping, however, really not appropriate for daily traffic. If you have anything more than a couple times a week vehicle traffic on a reinforced grass pavement, you're going to find that the grass wears out. The pavement system still continues to work in that it works hydraulically and the soil stays in place, but that just visually it changes its appearance. Each of the systems has appropriate applications, and then with any permeable pavement system, certainly looking at areas of unusually high pollutant or fine deposition is another critical issue. So where we might have an unusual pollutant load, like obviously at some industrial settings, probably not appropriate use for permeable pavement. Where we're going to have an unusually high permeable loading like that, or adjacent to an area, an unpaved area where we might have a significant amount of tracked materials coming onto the pavement where we have, but in most areas where we have relatively normal amount of pollutant loading, we can usually find a permeable pavement system that will work. Material specifications, that will be discussed within each of the topics here. Again, and design. Each of the pavement types, be they flexible or rigid, have design criteria to select the base and the site preparation and the material design itself, and so on. So the installation and construction and the protection of the work are all going to be relatively common to each of these. We want to really plan ahead. My experience working with permeable pavement, the most difficult issue that I've faced is the maintaining site access and actually being able to construct the project without compromising the permeable pavement areas. That's been the single biggest challenge. However, in locations where we've been able to be creative and address that by construction sequencing or certain remedy procedures or protection procedures, it can be quite seamless. And then maintenance, I think, which is probably the other big issue that's common to just about any stormwater management practice, and certainly true for LID practices, is ensuring that the proper maintenance is provided. Now, and so there's an entire module on low impact development O&M. One thing that is certainly true of permeable pavement is, and most LID strategies, is that if maintenance is not provided, it's a lot more obvious in the case of an LID feature, because so much more of the stormwater is managed on the surface, so much more of the BMP's function is sort of visible. Unlike a filter vault and an underground detention vault, could be full of sediment, could be running in bypass mode 80% of the time. The filter could be clogged, and no one knows. And so I think that but with LID, you're not afforded that luxury. I think if you go out and your permeable pavement has been compromised, sometimes, not always, but usually it's visually obvious, or it's obvious by some ponding that's happening, and certainly is the case with bioretention and other strategies. So some of the key features: who is going to be using this facility? Is this a PED facility? Do we need to think about the smoothness of the surface from a bicycle or shopping cart point of view? Or is this an overflow parking area where we just need to provide incidental access for a fire truck to set up and have outriggers, but it's really not for everyday use? I think you saw in an earlier slide the pervious bike lanes that I worked on with the city of Bellingham, and that was a very specific design to create a filter that's sufficient to basically receive runoff. And so it's going to have an accelerated maintenance requirement. But it's also, we went for a nice kind of a 1/4 inch round rock pervious pavement, which we were able to get very, very smooth, which would be acceptable to bicycles. So, for example, in a parking lot, we want to consider, it's a relatively low use, but we want to consider torsion. Probably wheel turning movements are going to be more common, and so forth. And then the aesthetics, and that's probably the biggest driver You can be very creative in a site design when utilizing different pavement types in different places and really create an interesting site design. Just down the way in Suquamish, we were able to create a nice informal drop-off area for the tribal elders in front of the Suquamish Community House by using a grid material that was partially filled with grass and partially filled with gravel, and it really worked. And it also achieved our fire loading. So it's really about, as it says here, one size doesn't fit all. So there's a lot of different choices, and they all have different applications. Design life, maintenance effort, these are all key considerations when we're choosing between asphalt and concrete or pavers. It's really what is our desired life. You know, some products have a lower first cost, and then potentially have a longer longevity. I think that's probably fair to say with the comparison between porous asphalt and pervious concrete and so forth. And so it's a question of what is our desired service life and how much maintenance is really going to be provided. One of the particular advantages of the pavers is the ability to recharge by vacuuming out the gravel, or if you have access to the specialized equipment to recharge your pavement, to understand what maintenance is available, and then to pick materials accordingly.